Dr. Lee, Professor Bengio, would you like to take the first topic?
Sure. So the first question is very dear to my heart, and also what I'm thinking about a lot these days. I believe that one of the current limitations of machine learning today is the ability of learning systems to generalize out of distribution. Most of the algorithms and theory we built over the last few decades rests on the assumption that the test data is going to come from the same distribution as the training data. But in the real world, whether you're building industrial systems, or you want to face AI challenges with robots or anything like that, you typically face a situation where the field or the situation where the system is going to be deployed really has a different nature from what it's trained on. And you might think that there's no solution to this problem, but there is. We now have several clues and handles on how humans manage to deal with this challenge, mostly using our conscious processing in order to quickly combine pieces of knowledge that we already have accumulated in a novel way. Even though these combinations are unlikely in the training distribution, we're able to do that, and it gives us a sort of combinatorial advantage that allows us to generalize well out of our training distribution. So this is what I'm thinking a lot about. If you look at any of my, well, not any, but at least half of the talks I've been giving in the last few months, many of which you can find online, you'll see this is a constant topic for my presentations. And I believe there's a lot of exciting work ahead of us to bring us to the next stage, in particular with deep learning. I think of this as deep learning 2.0 that incorporates these new inductive biases that humans seem to be taking advantage in order to generalize out of distribution.
And let me chime in. I very much build on what Professor Bengio talked about. I've started working on conversational AI since college. And the way I see us moving forward with a human-machine interface is towards what I call a delegation interface. Today, our interface with the computer is very much based on direct manipulation, keyboard, mouse, multi-touch, but language is our most innate way to communicate, a natural way to communicate with people. And we've been unable to do that most naturally to date, but we see a lot of breakthroughs, some building on this technologies that Professor Bengio is talking about, building on people's capabilities, but also we see advances in natural language understanding, in particular with transformer and its follow-on technologies. We now see improved capabilities of generating natural language. I think it's natural for that to move into, obviously, into speech recognition, machine translation, but also towards a delegation interface. And what that is today, to a search engine, we used to tell it a keyword or keywords, and we find some web pages. Then, with improvements at Google, we're able to describe a question. And using smart Q&A built on deep learning, it's able to find us very reasonable answers most of the time. But why stop at finding answers in web pages? Why not just get it done? Now, Alexa obviously does some of that, but still, we're asking one task at a time. We're using, for example, Amazon Alexa to browse gifts and then have it sent and delivered to people. Why wouldn't we want to be able to say, send my mother a birthday present, and it knows all the knowledge about me, how much price I'm willing to pay, who is my mother, where does she live, what kind of gift does she want. So that kind of understanding of the intent and ability to translate it into action, I think is a very exciting next step. And that couldn't be built without some further advances from deep learning. And I feel just as computer vision has seen waves and waves of breakthroughs, I very much would like to see natural language understanding undergo the same kind of improvements in the next decade. I think another question was AI research to industry application. Professor Bengio, would you like to start on that?
Sure, I'll be very brief. I think this is tough, and I see two aspects to this. One is social, and the other is technical. So on the social side, I think a big challenge is to integrate all of the people on the pipeline from basic long-term research to product groups, and create a culture that makes this possible while keeping the not just keeping, but cherishing the kind of freedom that researchers need to make true innovations. On the technical side, you need the tools, software tools, to make the transition from the research to development and products as efficient and quick as possible. And it's not easy because the needs, for example, in terms of flexibility of one group versus the other are different, but it is feasible.
I would look at AI's industrial applications in two categories. First is disruptive. That is, AI infused into an idea basically disrupts the industry and turns it upside down. And examples of that would include how autonomous vehicles will ultimately change completely the transportation industry. In some sense, Alexa is changing the speaker industry, a much, much smaller one. And actually new insurance apps like Lemonade in the US and Waterdrop in China are potentially disrupting insurance as an industry. I think those have all that they need. They have industry experts working with AI, disrupting, that's great. But I also think the disruptive type is the smaller type. I think much, much more AI's impact in the future will be incremental improvements, incremental but huge in terms of global GDP, using AI to improve every website, every financial institution, every HR, finance, banking, loan approval, medical diagnosis. It's incremental, but because the traditional businesses like healthcare, retail, and education are so big, even a few percent improvement will lead to trillions of dollars in incremental GDP. And that's where I see a big issue. Disruptive, I think naturally, that the AI disruptors and the industry disruptors are coming together to beat the giants and change the industry. I think that's generally going to go great, but that's a small percentage. I think there's so much low-hanging fruit. PwC and McKinsey have estimated $15 trillion of net incremental GDP, most of it built on these incremental changes. Improving a few percent of default rate and so on. And I think the big issue is that these traditional companies really don't know what AI is, and they think of this as too much of a science fiction, and they don't realize it can benefit their business right now. And the tools are not easy enough for their IT departments to undertake. So I think that is something that's critical, is whether it's through companies like Element AI and some of our investments to help the traditional industries, or for them to have a way to have easily accessible tools that can be directly used. So I think tools, education, and helping traditional industry embrace AI and reap the benefit, that's the big thing that I see. So I think the second section is on COVID and COVID-19, and what kind of how it has accelerated progress in AI and adoption, and what are the risks associated with that. And I'll start with some examples that I see. Living in China is really quite interesting in these times. One example is when you talk about social distancing, it's certainly that's caused a lot of AI applications. We don't really want people to be delivering things in hospitals. We want robots to do that. And for people in quarantine, which was the mode I was in when I returned to Beijing. Interestingly, in my apartment building, I never saw any people when I was quarantined in my room because a robot delivered everything. So with accelerated e-commerce, food delivery, the robot could take care of everything and truly deliver a contactless environment where it minimizes risks. So that's one example. In terms of risks associated with that, I think if we carry that too far, we'll lose our contact with people. So that is not something that's desirable. Another aspect is clearly AI and healthcare, I think, will be a big opportunity. One example is we invest in a company called In Silico Medicine, which is using GANs as well as generative chemistry to design new drugs in general. But with COVID-19, they took a few weeks to use their platform to design new molecules that can target the main viral protein responsible for replication. So that's another interesting, and there are many examples. I'll just give that one. The last example I'll give is potentially a little bit controversial, which is contact tracing. And there are many parts of the world that have successfully built contact tracing. Mainland China, Korea, Taiwan, Israel are some examples. And it's done with a lot of signals, including from in some cases from telcos. And I think in US, Europe, and some other countries, that's viewed as invasion on privacy. So that is the risk associated with it. My thought is that I think for the countries that cares deeply about privacy, I certainly understand and respect that. But I think one has to think about privacy in the context of a public health issue or personal a health issue, and the country should think about during public crisis, is there a way to allow the contact tracing so as to effectively control the spread, and then when the pandemic is over, have a commitment to go back to the norm. I think it's an idea I want to throw out there because not every country views privacy the same way, but I do think viewing it in the context of other important prerogatives and imperatives is something that countries should do, because the countries and regions I mentioned have been more effective in controlling the spread. But the countries that care more about privacy might consider doing it during periods of national emergency because it is proven effective.
All right, I'll talk about actually two topics that Dr. Kai-Fu Lee mentioned, in which I've been involved. So one is drug discovery, well, actually in this area and many other areas of science, I've been really amazed to see researchers from all over the world, companies, startups, large companies, get into projects that had as a first goal to do something useful to fight the pandemic, and not necessarily focusing on the immediate question of profit. Because if we can do something that's going to help us fight the disease and shorten the time we spend in the pandemic, it's going to help everyone, and including us. So on the drug discovery side, I'm involved in several projects involving graph neural nets and reinforcement learning, active learning, in order to discover new antivirals. This can be done using repurposing of existing drugs, in particular new combinations of drugs, because there are just too many of these combinations to be tried in chemical and biological assays. So you want to use machine learning to propose candidates that have a good chance of being successful. In the case of discovering completely new molecules, the search problem is even more amazing, right? So it's not 10,000 times 10,000 pairs of molecules. It's 10 to the 60 possible molecules that we would like to search through. And of course, there's no way we can actually try every one of them, even in the computer. And so we need good search policies that can direct their attention in just the right places. So that's the kind of research that I'm involved in right now. And we are hoping to reduce considerably the time for discovering good antivirals using these ideas. On the contact tracing side, most of the contact tracing that exists out there doesn't use AI. It's basically just using a very simple heuristic that if you've tested positive or you've been diagnosed, the people you've been in contact with should quarantine themselves or something similar. However, the information about the fact that a person is contagious is something you can get much earlier than when you get a positive test, except that it's uncertain information. So for example, if the person has symptoms. And so we've done a study showing that if you use machine learning to predict whether a person is contagious and how contagious she is, using self-reported symptoms, for example, you can drastically reduce the time to send these warning signals to the people you've been in contact with and reduce the spread of the virus. So I think there's an interesting potential to actually use AI in contact tracing. And of course, there are privacy issues, and there's an interesting tension between the needs of privacy and the needs of machine learning. Privacy wants less data to be communicated, and machine learning wants more data to be able to learn from or communicate useful information. In terms of the abuse of contact tracing, I think there's a lot of concerns in many countries, and that's why these privacy protecting technique that exist should be used in order to reduce the risks. And the good news is that it's possible to do that.
Right. The other topic that was asked is how AI can help us build back, enable our future economy and society to be more resilient and sustainable. So I'll start on that. I think one aspect, is future prevention. Once we've been through this once, I think we'll really want to find a way to avoid it. Earlier for the COVID-19, there were a number of companies, in particular a Canadian company actually, Blue Dot, says that they've used natural language processing, machine learning to track and report a potential disease spread in the very early phases and send alerts to their clients. I think such technologies can be much better built with a greater amount of data feeding in with much higher accuracy of prediction, and also sent out on global institutes, so that I would anticipate future sensors, wearable devices, tracking in hospitals, and aggregation at a national level, and reporting potential issues in the future, I think should help the next time be much, much better, should there be a next time. We all know the exponential rise of epidemic is such that you got to catch it earlier, otherwise it could get out of control. That's one aspect. The second aspect I want to talk about is the accelerated digitization and automation that is inevitable today. There is obviously a good side and also a challenge that this brings up. When I talk, so in terms of increased digitization, I'm talking about, we're having this session online where a lot of us are working from home, and many kids, 1 billion globally, are studying, having education online, and that is changing our habit in terms of what we can do online, and that can lead to much greater efficiency. It changes our habits. Would have been very difficult to change many of the activities we now have online before, but now with COVID-19, that's changed. And also, once workflow at work is digitized, that means many people's job we can consider, can it be augmented, assisted, or made more efficient, and of course possibly replaced by AI, using technologies like, you can imagine using RPA as a way to look at back office and other job now that it's been digitized. Before, if people had to go to work and meet face-to-face and write things on paper, very hard to digitize that work, but now things may be different. And before, think about us looking at each other, right? And we all know technologies can be used to reproduce the digital human relatively accurately now, but in a couple of years, probably indistinguishable, so that you couldn't tell whether you're seeing me or a digital version of me. And when such technologies arise, there are very good places to use them, such as customer service, sales, and so on. And all of this, of course, leads to potential job displacement, which is an issue, but it creates value and economic value. Similarly, we can think about automation. A lot of companies are hard-pressed on the cost of labor when they're facing financial trouble. They are considering replacement, automation in warehouses. Amazon has had some cases where it's basically the epidemic spread among their warehouse workers. So companies have a lot of incentives during COVID-19 to automate. And once they automate, they won't go back. And that has, again, similar implications. That is, companies saving money, spending less money, getting better bottom line, greater efficiency in the economy, but it's also potentially making it harder for people to come back to their jobs. And there needs to be a transition and retraining for people to take on jobs that aren't so easily replaced. So I think it's a double-edged sword, creating a lot of value, but also making it important for us to look out for potential unemployment and the need for retraining.
Thanks. I would like to add a few things. I think that as we're building more and more powerful technological tools, especially using AI, these can be used for greater good, or they could be used to continue to concentrate power in the hands of a few. And there's a real danger that these very powerful tools become powerful weapons, for example. There's a real danger that even the kind of fluidity and competition that exists in markets could be corrupted if just a few players ended up controlling the technology, or a few countries ended up controlling the technology. So there are many ways in which those technologies can eventually hurt us, which means we have to be mindful about the social impact of AI as we move towards our future and construct it. We need to allocate a good part of our efforts in projects that clearly are beneficial for humanity. That's why I care so much about AI for good applications. That's why, for example, using AI for fighting climate change is so important and profitable. But we also need to think about governance. Governance is at every level. So it starts within each company and it ends at the level of the whole planet. It's only with plant-wide governance that we can coordinate our efforts properly, that we can deal with the global challenges like climate change, but also challenges on the job market, challenges in terms of the use of AI, for example, in the military, that could disrupt the overall balance of things. So we need to get collectively and individually wiser in order to use these powerful tools in a way that's going to be sustainable and allow us to avoid future crises.
So then the next topic is, I think, following on Professor Bengio's thoughts, is ethical responses of uses of AI for good. And I'll give some examples from our perspective, and then Professor Bengio can probably add more on the climate change. So at Sinovation, which is a venture capital firm, we very much want to see AI applied for good. So our AI efforts are focused on a number of areas, two of which I think are particularly interesting from a responsible use of AI standpoint, and they are on healthcare and education. And these actually are both blossoming. So I think these are profitable investments, but these are all investments that I think will lead to a greater good. Healthcare, these two segments, I think, other than obviously they're good for humanity, interestingly, they reflect on what's something AI is good at and what's something that people are good at. In my book, AI Superpowers, I talked about AI having trouble, perhaps for some time, in being able to be creative and strategic, but also at the same time difficult in having compassion and empathy. So a very good symbiotic use of human and AI is where AI can be used for optimization and the routine work, and the human elevates to creativity and compassion. So I can envision that in healthcare in the future, the doctor will become more of a compassionate caretaker, caring deeply about patients, communicating with them, reassuring them that they are being treated correctly and will have a good chance for recovery, thereby giving a higher chance for the recovery for the patient. But AI can be used for analyzing radiology, MRI and CT, and proposing diagnosis with different likelihoods and outcomes using DNA sequencing as an input to give higher targeted precision medicine. And also AI can be used to assist the scientists to have a much more output in drug discovery. So we're very much looking at that symbiotic combination. Education is particularly interesting on an online scenario. We're invested in a lot of companies in China for online education, and we're finding that AI is actually very good in doing many of the routine things that teachers do. For example, grading homework, assigning homework, grading exams, and actually giving drills and assignments in a way that's targeted for each child's student's individual needs or trouble areas, much better than the human, because AI can give a different assignment to each person so that they're staying at their level. Of course, recorded lectures are good, but actually we're finding that virtual teachers, interactive virtual teachers, when it's at an basically an entry level where the conversation is more or less driven by the teacher, AI can do a pretty good job in a interactive scenario as well. And this will save a lot of time from the teacher so that the teacher can become more of a coach, a mentor, help each individual child and help them gain creativity and teamwork skills and communication and compassion. So these are the efforts we're putting a lot of our attention on, and we think these are two areas that are both good AI for good, but also very profitable and investments that will be making a lot of money for our investors.
Thanks. So I agree that I mean, healthcare and education obviously are central areas of AI for social good. I mentioned already climate. There's already a lot that is going on. For example, that could also be very profitable. So one of the projects that I'm involved with that is actually very closely related to the project on discovering new antivirals is discovering new materials. So we can use the same kind of deep learning methods to generate, synthesize, evaluate new candidates for materials. And there are two typical uses of materials that are really interesting in the context of the climate crisis. One is for carbon capture and the other is for batteries. So normally the design of these materials takes a very long time, something like 10 years easily, and which is even worse than the time for finding good candidates in the case of drugs. And so if we can take advantage of this ability of machine learning to acquire knowledge from the examples, the candidates that we have already tested in order to propose better candidates, we might have an impact on that front. Now, I think there's a bigger question and a bigger problem when I talk to, for example, grad students, entrepreneurs. Unfortunately, I think that if we want to really encourage the ethical and responsible use of AI, we have to change our culture. I believe that the culture we have right now is changing in the right direction, but not fast enough. We have to create a culture which is not just focused on, say, better science in the case of researchers or maximizing profit in the case of entrepreneurs, but also thinking about society, thinking about the social impact of our work. And it's not just the engineers building products, it's also the researchers thinking about what problem to work on, what data to work on. And it's not just something about individuals, it's something that we have to do collectively. Governments have to get involved in changing the culture, the corporate culture, the scientific culture. They have to invest in AI for good applications. They have to change the education system so that engineers, scientists would learn formally, not just about their particular corner of science or engineering, but also about enough about ethics, about social sciences, to be at least in the posture of understanding that they know very little outside of their field. And then when it comes to society and the impact of our work on society, they have to be humble and collaborate with experts from usually many different areas in order to make sure that their work is going to have a positive impact in the world. So.
Okay, I think our last question was, what's an ideal future with AI look like for you? Professor Bengio, would you like to start?
Well, I think it is possible to build a virtuous cycle in which AI is going to help us to build a wiser and more fair society. For example, right now, we have some issues with social networks and a lot of misinformation going there. And people are starting to build AI tools to try to filter the garbage from the correct discussions. But I think we need to be much more ambitious than that. The way I think about ideal future societies involves the ability to have rational, collective, and inclusive debates between everyone who can contribute to the debate before we take collective decisions. And right now we don't have the tools for this. Our social networks are broken from that point of view. They don't really work to help us discuss rationally what's best collectively. So I think AI could be used as well in that direction. And if we're able to do a few steps in that direction, it may help us build a wiser society, a more just society. And in turn, if we are able to become collectively wiser, then I think we'll be in a better position to use AI in a way that's beneficial for humanity. So there's this virtuous cycle, but of course it can also turn into a vicious cycle if we do the wrong things. So we have to be really careful.
Right, and great. My thinking is that I think we are the fortunate generation in which AI is maturing, at least narrow AI is maturing to a level where we can be symbiotic and really get to focus on what we're good at. And while AI will take some of the routine work and jobs away, but it's really an opportunity for us to be liberated from routine work and do the things that we really love. And I'll close with one of my favorite quotes, which was from John Adams. It was very optimistic, didn't quite realize with his generation, but I think if we worked hard on being the symbiotic opportunities with AI and looking at what humanity really exists to do, I hope we can reach this kind of an outcome starting with our generation. And here goes the quote. I must study politics and war so that my sons may have liberty to study mathematics, geography, commerce, and agriculture, in order to give their children a right to study painting, poetry, music, and architecture.
That is a lovely quote. Thank you, Professor Bengio and Dr. Lee. The questions that are coming in fast and furious, we have on screen now. If both gentlemen could please take some of these questions. We apologize to the attendees for not being able to address them all, but we've captured some of the most pertinent and popular questions. Prof. Bengio and Dr. Lee, please.
So I see a question about the opacity of deep learning system and explainability. So let me say a few words about this. Actually, humans have trouble explaining their decisions as well. So if you study a little bit human cognition, you realize that there's a lot in the way that our brain computes that we don't have conscious access to. Now, there's a part of what we do that we have conscious access to, and that's the part that we are able to report verbally. And so we can explain that sort of tip of the iceberg. And that's very useful, of course. It's very important, and it's really important to build the next generation of deep learning systems to be able to have that tip of the iceberg, that to be able to reason at a level that's verbalizable. So I think there's research going in that direction, and I'm excited by that. But we should not expect from machines, whether those that exist now or which will exist in the future, much more in explainability than what we already request from humans. And so with that in mind, I think we can make a lot of progress in that direction. But there are aspects of the world that are fundamentally not reducible to a few sentences. And so although we can make a high-level abstract summary of some of these things, it's never going to be a complete story for most interesting decisions made by machines or by humans.
I'll take a question on the possibility of bias. It's a topic that comes up a lot in the industry. There have been some bad examples where some companies didn't do as good a job so as to basically build AI that appears to be either gender or racially biased. I think that is akin to the early days of programming. I remember when I learned program, GoTo was an acceptable construct to use. And then over time, people said, well, that leads to a lot of buggy programs. So let's build programming languages where we don't let people use GoTo statements. And then the tools basically made more predictable and less buggy programs. So I think we also need similar tools. I think tools for, especially as non-AI experts start to use these tools to build these engines, which may affect people's lives or jobs and so on. So one of the reasons for cause of bias is that the training data may not be well balanced or not enough of them. So that could potentially be detected earlier. Another element of bias is maybe it's using some feature that is predicting an outcome that would appear like it's racially or gender biased, then we may need to reconsider those features. So I think better tools will go a long way to reducing bias. And the other really important element, I think Professor Bengio mentioned earlier, is to make sure that people understand, that AI engineers and researchers understand that it is their responsibility not just to get good results, but also to be watching out for bias and other issues, and that education about the importance. For example, medical doctors have to make basically swear that they will put people's lives at the top of their priorities, and their training and their beliefs are built around that. I think AI engineers will need to have a multidisciplinary training, understand their responsibilities, and not just rely on the tools, but they themselves need to make sure this is minimized. I feel confident that over time this will be resolved, just like problems with programming languages, because I think people mean well. They do, once they understand the consequences, they'll focus on it. It's kind of an early problem that emerges. And I also believe ultimately AI should be less biased than people. We have seen examples where I think Israeli judges were more lenient after lunch than before lunch. So people's bias could come from all sorts of things. You can't, and I think AI isn't born with that. AI basically uses algorithm and data. If the tools are good, I think we should lead to a less biased process if we're able to be careful about these things. Okay, I'll start on that one. Clearly, the industry that has benefited by far the most is the internet industry, because they have so much data. Companies like Google, Amazon, Alibaba, and so on. And that has led to a lot of power, and they're the most powerful companies, and some of the issues that Professor Bengio has brought up. I would say after that, the financial industries would have the next best opportunity, because they also have a lot of data, and their business results are connected to the data itself. I think after that, I believe healthcare is another big one. I think retail and manufacturing are also big ones. And again, I would tend to say traditional industries infused with AI are probably the biggest opportunities from a maximize economic value point of view.
I would like to answer actually another question that I've seen in the question list about an issue that exists with current social networks, which, as the person says, reinforce and entrenches current views and creates just these bubbles of articles and polarizes the political views. So it's an interesting question. It turns out one of my friends, Philippe Baudouin, just created a company called Waverly, which aims to address this very difficult challenge. And his idea is, instead of relying on people voting, yes, no, or liking or not something to know about what is good for you, he suggests to use natural language in order to get at people's real aspirations at a conscious level, rather than at the unconscious level when you like something because it's flashy or something like this. It plays to your instincts. Instead, he wants to explore a kind of recommendation system which is based on natural language interaction, through which we can discuss about what the person wants to know about, what's the person's interests, what are her aspirations, and so on. So I think this is an interesting direction, which actually requires also some advances in fundamental techniques of the kind I was talking about earlier, dealing with representations of high-level semantic concepts and natural language understanding.
And I'll take the second question on the screen about what can government do to help private sector make progress in the adoption of AI. I've seen programs throughout the world that work well, and the programs that don't work so well. I think what doesn't work well is for the government to pick winners and losers, because that's not what government officials are expert at doing. When they start doing that, that's problematic. I think it is perfectly possible for governments to strongly support AI, and I think the most effective ways to do that, I think, are in two areas. One is, think about what are the infrastructure that private enterprise cannot possibly build, and assist the private enterprise, because I truly believe that the venture capital system and entrepreneurship working with academia is the best engine, but sometimes there are things they can't do. One of the things that we in the private sector cannot do is redesign, for example, the highway, redesign the city. So for example, in China, there are efforts that will make the roads smarter to talk to autonomous vehicles to avoid accidents. There are efforts to look at, does it make sense to split the downtown area to two levels, separating pedestrians and cars so as to minimize the loss of life in terms of car hitting a pedestrian. Those are the kinds of efforts, but obviously, 5G, making sure 5G is pervasive would be another aspect, but these infrastructure investments are good. The second type that I think is useful is something actually I think Israel, Singapore, or the two countries that started and widely adopted in China, which is the idea of helping basically the government picking the areas that are important and picking the venture capital firms that are trusted and proven, and becoming an investor, LP, in these areas, and giving some of the upside to the GP and LP. So these kind of, so for example, we in the investment industry see that most of the money are made by very late stage companies that do purely financial transactions. What is tough is earlier stages. What's toughest is angel stage and seed stage. And it's just very hard to run a fund that's profitable. But if the government says, I'll put in 40% of the money in 20 GPs that are viewed to be qualified in the following areas: early stage AI, early stage bio, and so on and so forth, because they're risky and the time to distribution is very long distant. The government takes 40%, let's say, and then when money is made, the government gives half to either the GP or LP. That kind of extra incentive, placing the judgment in the hands of investors who are experts, I think has proven to work very well for Israel, Singapore, and China. So I think there should be more of that.
Let me say a few words about the questions from David Hardoon, which are really about the cultural differences between countries regarding AI. So I think that those differences indeed can make a difference, but it depends for what. So if you consider basic research, which is where a lot of the important ideas that are going to transform AI in the next few years are coming from. It is true that you need a culture that cherishes unconventional thinking, that allows people freedom to try things and that may not work, to give people enough mental space to explore without putting too much pressure on them. So this is what you normally get in good academic environments. And not all countries have developed that kind of culture, but I think it's something that all of us have inside of us, at least when we are children, and that can be cherished in any country. It's a human thing. Regarding the the industrial side, I think that we've reached a point where a lot of the deployment of AI can be done using engineers who have studied for a few years these tools and understand the basics of them, and they don't need to be researchers in order to be able to discover new ways of applying those techniques that nobody had thought about before. So that kind of innovation is something that can happen if there is, again, a different kind of investment in the human capital, which gives freedom to these engineers, again, to try things that may not be guaranteed to work in a very short time. That requires, for example, a culture of investment that's willing to take risks, especially long-term risks. So this can bloom in any country, but it's not all countries are at the same stage for both of these aspects.
Yeah, I'll add a few words to the same question. I think Canada is a phenomenal country in AI. Right, 2 of the 3 Turing Award recipients in AI are in Canada, and you have great universities, and the government is very supportive of AI. And I've seen some of the government projects, and they're quite good. The one challenge of Canada is that the population is very small, and AI does depend currently on a lot of data. And in order to, especially when you want to use data to build a great app and then use the app to make money and the money to get more users, it becomes a virtuous cycle. So I think what I would suggest to Canadian entrepreneurs, VCs, and government is really be thinking more about markets outside Canada. I think, don't view every AI project has to be Canada first. I mean, US and Canada are very close, so why not launch your product in North America and not do Canada first? That would be one way. And I know there are a lot of Chinese companies that would love to have Canadian expertise come build products for the Chinese market too. So I think it's the large market is a big benefit.
Thank you very much, Dr. Lee and Professor Bengio. It has been such an insightful session. It has been so lively, the chat function, people connecting, the questions that came through fast and furious. We would really want to thank you for the time and for the great insights that you both shared during this very precious session. And I would like to thank everyone for joining us. We had a very good turnout with over 1,000 attendees from literally all over the world. So we thank everybody for joining. We thank you for your participation and, more importantly, your engagement during this session. And we would invite you to check out the replay on our YouTube channel, which will be shared within the week. And do provide your feedback when you leave this this webinar. There will be a questionnaire, so we are always eager to improve on our sessions. But importantly, follow us. Let's continue the conversation. Follow us on our social media channels at SG Innovate on LinkedIn, Facebook, Twitter, and to our partners, Element AI. Thank you very much. To our speakers, thank you for the honor, for your participation at this very special event. Thank you, everybody, and have a great day, great evening for all of you joining us from all across the world.
Thank you for organizing.
Thank you. Bye-bye.
Thank you. Bye-bye.